Hello students, and welcome back to another lovely day of physical science. In this lesson, we are going to solve for how to use a line of best fit and kind of the purpose of a line of best fit. Sorry, I wanted to make sure the camera was actually still going. So, what we're going to be doing in this problem is we are going to be analyzing, is there a relationship between the fat grams and the total calories that are in fast food? And if you look at this, you can kind of see, okay, hamburger, 9 grams of fat, 260 calories. Cheeseburger, 13 grams of fat, 320 calories. Quarter pounder, 21 grams of fat, 420 calories. So it seems like as the amount of fat goes up, so is the number of calories. But we actually want to be able to go through and predict this. Let's say I wanted to make a burger with 45 grams of fat. Well, we actually want to be able to predict how many calories would that be, or vice versa. Let's say for some reason I want to make a burger that's 1,100 calories. Well, about how many grams of fat would be in that burger. Those are different things that we can solve for using a line of best fit. So here, if we go through and we plot all of this data, you'll see a graph that starts to look like this. And you notice a pretty linear relationship. It looks like there's a pretty good line that can be drawn here. So we have our title up top, we have our energy calories are on our y-axis because those are going to be our independent variables, and fat is going to be our dependent variable. So the amount of calories changes based off of the amount of fat. So if I wanted to draw a line of best fit, I might draw one that looks like this. Again, a line of best fit is your estimation. So you might have a line of best fit that looks something like this. That's just fine. Or you might have one that even looks like this. Again, it's an estimation. It's meant to just be an average of all of these points. So if yours isn't the exact same as mine, that's okay. But since this is the line that I drew, I'm going to pick 2 points that are on this line. I'm going to pick this point, and I like to pick this point because it pretty well intersects right here. So I can pretty easily know that this is the point 12 and 340. Remembering that your x value is always written first, y value is written second. For my second point up here, I'm going to pick this one again. You want your points to be, pretty far away. You don't want to pick 2 points right by each other. But this one intersects, right on this line as well. And this is the point 32, 580. So again, when you do this on your own, your points might be a little different than mine. It's okay, because you estimated your line of best fit. So if you feel comfortable, I would actually like you to pause the video and go through and try and solve for your line of best fit that is solve for your y equals mx plus b right now. Some of you may have seen the answer already. That's okay. If you tried this on your own, your answer should be somewhere close to y equals 12x plus 196. If you use the same points that I did, this should exactly be your answer. If you use your own line of best fit, well, your answer will be pretty close to this. So if you got that correct, you can actually fast forward onto the next slide. If you did not get this, please follow along as I solve for this. So first thing, you choose your 2 points that are on the line of best fit, which we already did. Points 12, 340 and 32, 580. Now what you have to do is assign each of these as being your first point and your second point. Well, I choose 12 and 340 as being my first point. So if that's the case, this is my x1 value and my y1 value. Then 32, 580 is my second point. Again, it doesn't matter which you assign as 1, which you assign as 2. You'll get the same answers. It's just what I did. So if that's the case, this is x2 and y2. So to solve for our slope, we're going to use that equation that m is equal to y2 minus y1 over x2 minus x1. So if I plug these in, our y2 value was 580 minus our y1 value, 340, divided by x2 value is 32, and our x1 value is 12. So now you plug that in your calculator, you take 580 minus 340, gets you an answer of 240, divided by 32 minus 12, you get an answer of 20. And that is going to give you a slope then, hence M stands for slope, of 12. And there you go. We found slope. Now what we want to do is we want to find the y-intercept of our b, find the y-intercept, which is the variable b. And what I always like to do is actually go back and look at our graph and get an estimate of what our slope might be. So if we go back to the previous slide, and if we were to follow our line of best fit, the y-intercept is where this line would cross on the y-axis. So in this case, my estimate's actually almost looking to be a negative number. Realistically, that's not possible because, you know, fat grams are going to have some sort of calorie, can't have negative calories. So realistically, my line maybe should have actually been further up here. But let's go through and actually solve for our line of best fit, or solve for our y-intercept and see what we get for an answer. So to solve for y-intercept, we're going to use this equation y equals mx plus b, and then there's a few steps to use here. So first thing, plug in the value that you found for m, which was your slope. Second step is plug in either your x1 and y1 or your x2 and y2 values. It's up to you. It doesn't matter which one. I just tend to use the one that I labeled as 1. So that's what I'm going to plug into here, which is why I have these written as yellow, you know, to correspond with the colors up here. And then third step is solve for the value of b. So let's see what this would look like. If I go through and I start plugging in the y values, we're going to get 340 is equal to, and then our m value, which was 12, our x value, which was also 12 in this case, that just happened to be, plus our value of b, which is what we're solving for, so we don't know that yet. Well, following our order of operations, that is, I think a lot of students call it PEMDAS, parentheses, exponents, multiplication, division, addition, subtraction, we need to multiply these first. So that's going to give us 340 is equal to 12 times 12, so is equal to 144 plus b. Well, now what we need to do is we need to try and get b by itself, since it's the lone variable. To do that, I need to subtract 144 from both sides. Whatever you do to one side of an equation, you can do to the other. And that's what's going to get b by itself. Since this is 144 plus b, and we need to do the opposite of this 144, which is subtracting it. And then, you know, since we subtract 144 from one side, we do it to the other. And therefore, 144 minus 144 cancels out. And you are left with 340 minus 144, so therefore b is equal to 196. And now we know our y-intercept. So if we go back and look at that graph again, you know, realistically my line probably should have passed somewhere up here, you know, so that way it would cross right around that y-intercept. But, you know, line wasn't perfect. And then to get your line of best fit, all you need is y is equal to 12x plus 196. So you just plug in your slope, plug in your y-intercept, and then you just leave y and leave x alone. And there you go. That is your line of best fit. Now, let's see what we actually do with that. Like, what's the purpose of a line of best fit? So here's an example problem. Let's say I want to make a burger that has 45 grams of fat, and I want to be able to predict how many calories does that burger have. What I would like you to do is actually go through and pause the video and try this out on your own. If you feel comfortable, I'll show the answer here in a second. If you need help, I will go through and do the solution. Okay, now that you have tried this on your own, the correct answer should be about 736 calories. Again, that can vary if you had a different line of best fit. If you're using my same point values, this should be your exact answer. If you got that, fantastic. You can skip ahead to the next slide. If not, please follow along as we solve for this. So to solve for this, first thing we need to do is figure out, well, what are our y values? What are our x values? In this case, since we have energy over here for our calories on our y-axis, well, those are y values. Y values are energy. Fat was on the x-axis, so therefore x values are going to be grams of fat. So what this question is asking us to do is to predict the calories of a y value when given an x value or given the amount of fat. So we're going to take the equation that we had on the previous slide, our line of best fit, and that is y equals 12x plus 196. So therefore, y is equal to, and what we're going to do now is take that grams of fat, and since we said that was our x value, we're actually going to plug that in for x. So therefore, y equals 12 times 45 plus 196. So we multiply those and we get y is equal to 540 plus 196. Therefore, y is equal to 736 calories. And that is going to be your final answer. So what this is doing now is, if you look at this graph, you'll notice the graph doesn't go up to 45 grams of fat. It doesn't go up to that many calories. So we're actually using this line to predict if I made a burger with 45 grams of fat, it would have about 1,100 calories. And that's the advantage of doing this. Or we try something else. We could predict, let's say we wanted a burger with 1,100 calories. How many grams of fat would it have? Sorry, I want to jump back to this slide. I just want to make sure I say this correct. 45 grams of fat would have 736 calories. I'm just worried I misspoke and said 1,100. Sorry, going back to this. A burger with 1,100 calories would have how many grams of fat? I would like you to please pause the video and try this question on your own. All right, now that you have had a chance to try this, the correct answer should be about 75.33 grams of fat. Well, let's take a look at why. So in this case, our y values again are still going to be our energy or calories. Our x values are going to be grams of fat. We want to predict the number of calories when given the amount of fat. Oh, and that's actually changed this time. We want to predict the fat when given the amount of calories. So y is equal to 12x plus 196. So what we're going to do this time is, since we are given the calories, we're given that y value, we want to plug that in for y, not for x. So therefore 1,100 is equal to 12 times x plus 196. So what we're going to do now is, again, we need to get x by itself. To do that, we need to subtract 196 from both sides. So plus 186 minus 196, those are going to cancel out. Then we take 1,100 minus 196, and you're getting an answer of 904 is equal to 12 times x. And now to get x by itself, notice this is 12 times x. To get 12 to cancel out, we need to do the opposite of multiplying, which is going to be divide. So we're going to divide both sides by 12. And again, 12 divided by 12 is going to cancel out. And that leaves us with just x on this side. So then we take 904 divided by 12, and we get an answer of 75.33 is equal to x. Therefore, our final answer is 75.33 grams of fat.